All right, your problem is a lot easier that I'm going to give you. This is a shape. They're spinning it around the y-axis. They've drawn it here for you. They want you to use shells, but it's a problem-solving thing, so it's easier without shells. So here is what I did. I graphed it. I did the mirror image, but this time the mirror image is going to come around the y-axis. So I fold the piece of paper across the y-axis. You have one earlier where you're spinning around the y-axis. This is what you're going to do. And again, I said they want you to draw shells, but I don't want to. Draw the mirror image and then add the dimension, except the dimension this time is going to be horizontal. So it's like you have a hole that's a weird looking cone thing, and the outside's a regular cone. So you have a cone with a curvy cone thrown out of it. So I do the same thing as before. I find the volume of the hole. The volume of the hole, if you go look at the hole, it touches this curve here. And the formula for this curve is 4x minus x squared. But I'm going horizontally, so I need to know how much distance in x to go. That's what makes this hard. So x goes from 0 to this curve. This is my curve. Y equals 4x minus x squared. But I need this in terms of x because I want x goes from 0 to x goes to something. So I need to solve y in terms of x. And that's why they wanted you to use shells, because this is hard. And this is the only time I'm going to use Mathematica. If you actually had to solve this using by hand, you'd have to use complete the square. You'd have to go on this side and make this a perfect square and then take the square root. That's why you get this x equals 2 plus square root of 4 minus y in here. So if you come across something on the test on the WPR like this, I would say that, hey, this upper limit would be x equals a function of y. If you absolutely can't solve it and that's the only thing that comes to mind because Dr. T screwed you up, I would say x equals f of y, pretending I solved it. It's totally very smart to do it this way. So here x is this guy here, so this is my radius, and my area is again pi r squared, and this guy here is pi r squared with my formula in there. My a starts at 0, my b starts at 3. How do I know that? Because that's where my picture starts and stops. I didn't actually draw it here. Oh yeah, they gave it to me. Let me see if I go back up here. It's and they didn't give it to me. My picture starts at 0 vertically and it ends at 3 because they gave it to me in the problem. I didn't write it down, but they gave it to me in the problem. So I have my a to b, but everything's in terms of y now. Spinning around the y just changes everything to y, and the volume of the inside turns out to be y equals 0 to y equals 3 of this function right here squared, dy. The cone on the inside, on the outside, it's going to straight lines, and that line is y equals x or x equals y, so it's super easy to solve it for y. And the radius is 0 to y, so the area is pi y squared, and my y still goes from 0 to 3. And then the big cone on the outside is this guy. So the volume of the cone minus the volume of the hole is the total volume. And hopefully they just ask you to set it up. So you try this one down here. It's actually pretty easy because here solving for x is easy. It's 1 over y. So your y goes from 0 to y equals 1 over x is easy. You can actually see it. You can see these functions. X goes from 1 over y here. So actually I would want here, instead of this, I would want x is equal to 1 divided by y. So you can solve for the x easy. You don't have to complete the square or anything. So you can just draw this. You're going to get a hyperbola. X goes from 0, starts at 0, and then y goes from 1 to 3. So they're giving you the chunks. And then you're spinning that around the y-axis. So your a would be 1 and your b would be 3. So if you do those 3 problems, and I think I gave you one hard one in there, if you can't get farther on that, do your best attempt to get on it, get as much as you can. I will go back either giving you credit on revisions for this past quiz, wherever your points need to be raised, I will raise them. This is going to help you study for the WPR, so that's my hope.